Hi everyone, this is your 2.2 notes. You should be on page 11 of your pink packet so that you can follow along with me. And as always, if I say anything or do anything that you are confused about, please make sure that you write down your questions so that when you come back to class, when we come back to class, we can have a conversation about it and make sure that we get that figured out for you. We have two learning targets for our lesson today, and both of them deal with 1A proficiency indicator, which means we're going to be writing equations. We're going to write explicit equations given an original equation and a vertical translation. And we are also going to write the translated form of a function. Now, I know that's kind of a lot of vocabulary, so let's dive into what those words really mean. Some of them should at least seem familiar. Explicit form, we talked about last year in Math 1 kind of a lot. For the purposes of this section, we're going to say that explicit form really just means a linear function in either slope-intercept, point-slope, or standard form. Those are the three forms that we've been working with pretty much since we started in Math 2 together, right? So any function that we write in one of those forms, we're going to refer to as an explicit function. We also have this idea of a translation. This is something probably new to most of you, but translating really just means that we're sliding a function. We can slide it up and down or left and right. Now, one very common example, or at least should be common since we just dealt with them, of sliding functions up and down really is just parallel lines. If I take one line and move every single point on it either up or down a certain amount, I've created a parallel line. And I've done that by just translating the original function. So we kind of talked about that a little bit in our task, and we'll dive into it a little bit more as we move through some of these examples. The last thing I want to touch base with here before we dive into examples is this idea of translation form. So it's really when one equation is written in terms of another. And we did that in our task. I think what we said was k of t is equal to p of t minus 30, or something like that, which really just means we started with this function p of t, and we shifted down 30, and that created this new function k. And again, that might not be the exact one from our video, I'm not quite, or from our task, I'm not quite sure, but I think that's right. But either way, that's our translation form, starting at one function, moving it either up or down, and we're ending at a new function. Let's dive into actually writing our own translations. We have three separate examples here. We could write translations from graphs, we could write translations from equations, or we could write translations from a table. And we're going to dive into how to do each of these. Let's start with from a graph. If we're working from a graph, we've got this picture that we've got going on, right? In the directions here, by the way, it's going to be super important for you to read directions on these problems. It says we're given the graph of a function f and its translation g. What that means then is we must have started at the function f of x. That's our original. We're going to call that our starting function. And then we translated or we moved it and we created this new function g of x. We're going to say that's where we ended then. When we look at our graph then, it's asking us in words to describe how g of x is related to f of x. Well, once again, g of x is where we ended. So I'm going to go ahead and highlight this function g, just so we can have our colors kind of match here. And we want to know how is that related to f of x, which is where we started. Well, when I take a look at this, I see that the green one, which is where I started, is above the pink one, which means in order to move from f of x to g of x, I had to move down. And now I just want to know how much did I move down. So all I'm going to do is count. 1, 2, 3, 4, 5. I had to move down 5. What that means then is that g of x is 5 units below f of x. So that's just what it means in words. G of x is 5 below f of x, okay? Now we want to take this and write it in this translation form. So again, we're starting at f of x and ending at g of x. And we just discovered that our translation, this k, is this moving 5 below. What that means then is our translation form is going to be g of x equals f of x minus 5. If I wanted to move down 5 units, then I'm subtracting. And literally that's it. We don't have to worry about what were the explicit equations for either of these, anything like that. We just want to know, how can we write g in terms of f? Well, g is equal to f of x minus 5, because we started at f and moved down 5 units. Let's look at how to do this from some equations then. We're given information about f of x and g of x. We've got these two separate equations, 4 of x plus 5 and 4 of x plus 10. Now, when we look at those, we should be able to recognize right away that those are in fact parallel lines. They have the same slope of positive 4, which means they are translations of one another. And you'll notice we've got two parts here. We've got part A and part B. So let's look at part A first. It says rewrite g of x in the form g of x equals f of x plus k. So g of x is going to be our ending function. So I'm going to go ahead and write g of x right here. G of x is equal to 4x plus 10. And we know that f of x is our starting function, right? That's just based on this equation that they gave us. They gave us the form they wanted in, which means we're starting at f of x. And we know f of x is equal to 4x plus 5. We need to figure out what that k value is. So how did we go from positive 5 to positive 10? We just need to look at these y-intercepts here. All right, when we're translating, and I kind of forgot to mention this on the graph, I just automatically picked the y-intercept because that is my go-to. We just need to pick literally any point on the graph and figure out how did it move from one to the other. So when we're given these equations here, we just focus on those y-intercepts. We already know the slope is the same, so it doesn't matter. We want to know, how did we go from positive 5 to positive 10? And the answer to that is we had to move up 5. So our k value is going to be 5, which means g of x equals f of x plus 5. Now you'll notice for part B here, we're going to rewrite f of x in translation form. So now we are going to be ending at f of x instead. And we're going to be starting with g of x. So you'll notice f and g just switched places. So now we're starting at g, which we know is 4x plus 10. And now we're going to end at f of x, which we know is 4x plus 5. So to figure out that k value, again, we're going to focus on those y-intercepts. We're moving from positive 10 to positive 5. And in order to do that, we had to go down 5, which means our k value is now negative 5. Now you'll notice these two translation forms, we used the exact same equations here, right? We had this set of parallel lines, these two lines, and all we did was start at F and go to G, or start at G and go to F. But the order does matter because you'll notice our translations were not the same. We had a plus 5 here, and we had a minus 5 here, because where you start versus where you end does in fact matter. So you want to make sure that you are very careful about labeling which function you're starting with and which function you're ending with so that your translation is correct. All right, so we've done graph, equation, now let's move on to a table. we need to rewrite g of x in the form g of x equals f of x plus k, which means we must be starting with f of x and ending with g of x. But now I don't have equations to look at, so I can't just focus on the y-intercepts. What I'm going to have to do then is focus kind of on all of these points. So if I'm starting at f of x, all of these are my starting y values. And I'm ending at g of x, so these are all my ending g values, or x values. No, my ending y values. I'm so sorry, I screwed that up. We are starting at f of x, so everything in green is where we are starting with our y values. We are ending at g of x, so everything in pink is where our ending y values are. That's where they end up. That was a lot of words, and I'm really sorry about that. Moving on. We need to just now pick 2 points that's easy to find, okay? It's easy to find the distance between. So I'm going to just pick this first one. I'm going to go from positive 5 to negative 42. What I need to do then is I know I'm going to be moving down, right? Because I went from a positive number to a negative number. I just need to know how much. Well, 5 to negative 42 means I must have moved down 47 units, right? If we kind of think about going from 5 to 0, that would be down 5. And then 0 to 42 is down another 42. So really, 5 plus 42 gets us to 47. And we can double check that with our other points. To go from negative 1 to negative 48, I can just subtract 47. To go from negative 13 to negative 60, I can just subtract 47. And to go from negative 43 to negative 90, I can just subtract 47. So it is a good idea to double check and make sure that this works all the way down on all of your points so that you have the correct translation. It works, and so that means g of x is going to be equal to f of x, our starting function, minus 47. Okay, let's talk about writing explicit equations. So all of these that we did here, we wrote translation forms. It was always f of x equals g of x and then a k value, or the other way around, g of x equals f of x and then a k value. I might not have switched it. I don't really know. Sorry, you get what I mean. Now we're going to write these explicit equations though, which means we're going to be writing equations that are in slope-intercept form pretty much. We're given this starting thing here. Let's see. We're given f of x is equal to g of x plus 4. Well, that's a translation form. That's like what we were just writing. So let's pick out where we're starting and where we're ending. When we look at this, we must have started at g of x. That's the function that we began with. So that means our ending function is this f of x. And the k value tells us how we got there. Well, we started at f of x, and then it says plus 4, which means we must have taken it and moved it up 4 to get to this new function, f of x. Well, we're also given g of x equals 3x minus 8. That's our starting function. Well, what we need to do then is take that starting function and we're going to move it up 4. If I focus in on this y value, this y-intercept, excuse me, it's negative 8. If I want to move that up 4, then I'm really just going to add 4 to it, and I get negative 4. That must mean my form for f of x, my explicit form, is going to be 3 over 4x minus 4. Now, I know for some of us that's a little hard to imagine, so I want to show you another way of kind of thinking about it. This ending function, f of x, has to be the starting function, which is 3 over 4x minus 8, and then we translated it up 4. And now if we look, we can see there's some like terms right here, negative 8 plus 4. That's where that negative 4 came from. So our explicit form is this f of x equals 3 over 4x minus 4. And that's it. That's all we have to do. We can see that f and g now are 4 units apart, and f is 4 higher. That's really what the translation form is kind of explaining to us there. So let's do another example. We've got f of x is equal to g of x minus 19. So we started at g and moved down 19. And we've got g of x, which is negative 5 minus 4x. So I don't know about you guys, but I do like the use of the colors here. And so f of x here is our ending function. G of x is our starting function. And this minus 19 must mean that we're moving down 19. So that's what this is. And then g of x is the starting function, and we're given g of x. It's right here. And f of x is the end goal. So we're going to take this function here, and we need to move it down 19. So if we pay attention to what this y value is, this y-intercept is negative 5. If I want to move down 19, that means I'm going to end up all the way down at negative 24. So my explicit form is going to be g of x equals negative 4x minus 24. Again, I want to show it the other way because I'm extremely visual. I need to really see where that's coming from, and I think a lot of other people are too. So I just want to make sure we're all on the same page. So let's see here. Our ending function f of x has to be equal to the starting function g of x, which is negative 5 minus 4x, and then our translation is down 19. Well, now when I look at this explicit equation, I can see negative 5 minus 19. That's where that negative 24 came from. And so my function is, oh, I wrote that wrong. I'm so sorry about that. It's not g of x, it is f of x. So sorry, I hope you caught that before I did. Our explicit function then is f of x is equal to negative 4x minus 24. I know there was a lot of vocabulary in there. I know there was a lot of f of x's and g of x's and things like that. So please make sure that you wrote down any questions that you have. I will be sure to answer them when I see you all back in class. Thank you so much for watching.